Okay, in this video we're going to try to understand the graphs of projectile motion. So when I look at graphing projectile motion, I want to look at how in the y and the x direction the position, velocity, and acceleration vary with time. So let's start with a horizontal projectile, and then let's look at an angled projectile as well. So if we start with a horizontal projectile, I think the easiest thing to graph is the x position with time. So let's call this x position 0, and then it travels to the right as it flies through the air. And we know that it travels at a constant velocity. So if I start at position 0, my x position versus time will be a constantly increasing line. Now the slope of my position time graph tells me my velocity, so a consistent, constant positive slope means a positive velocity. A flat slope of 0 velocity line means the velocity is not changing over time. No change in velocity means a 0 acceleration. So that's a really easy set of graphs for the constant velocity motion in the x direction. Now in the y direction, it's accelerating according to gravity, negative 9.8 meters per second squared. So let's start by looking at its height versus time. So let's say that the bottom here is y of 0, and I start at some initial y position above that. It starts with a y velocity of 0, so my height versus time graph starts flat. Now then, over time, as it falls to the ground, it gains speed, it gains negative velocity, so it's got to gain slope downward. So this is a curve, downward curve like this, where the velocity is 0 here, and then negative as it gets closer to the ground, because it's gaining a negative velocity as it falls towards the ground. Now if I look at my change in position versus time, I can just start at a change in position of 0, and the change in position gets more and more negative. So make sure you don't confuse the change in position versus time versus the height versus time. They're really the same plot. It's just one is moved above the y-axis where position is 0, and one is just showing my change is negative over time. Okay? Now the velocity versus time. I start with an initial y velocity of 0. So I start with initial y velocity of 0. And then over time, as it goes through the air, the y velocity gets more and more negative. It's a downward decreasing line like this. And what is the value of this slope? That is the acceleration, which is negative 9.8. So I'm going to have a constant negative acceleration of 9.8 through its flight. All right, now let's shoot it up on an angle. So you'll see that some of them change, some of them stay the same. So for an angle projectile, I'm going to have some initial, let's just call this a position of 0 for x and y. So I'm going to have some initial velocity in the x direction, and that's going to stay constant throughout. So my x position versus time stays the same. I have a constant positive velocity, an acceleration of 0. So really those are the easiest graphs to identify. Now my y position begins with, I begin at position, so my height versus time begins at a position of 0, right, on the ground in this case, and then it's going to gain height, and then it's going to fall back down. So it has some initial y velocity that's positive, and then that's going to go to 0, so it flattens out, and then it's going to get negative. So really, the y position versus time graph is a parabolic arc, just like the path of the projectile. Now in this case, since I'm starting at a position of 0, my delta y versus time and my height versus time graph are really the same. Velocity versus time, now I start with some positive initial y velocity. So it starts positive, and as it goes towards the peak, it has a velocity of 0, and then as it falls down, it's gaining negative velocity. So if I look at those points, my y velocity is going to decrease over time. I'm going to have a negative slope, but it's a constant slope because the slope is still negative 9.8. Just because I shot it up in the air doesn't change the acceleration due to gravity. Gravity is always accelerating it downward at negative 9.8 meters per second squared. So my acceleration graph, whether it's horizontal or angle, always looks the same for my y acceleration, always negative 9.8 meters per second squared. So hopefully that helps you to understand how we were to plot the position, velocity, and time, and acceleration time for an angled and a horizontal projectile in both the y and the x directions. And this should help you understand the constant velocity motion in the x versus the accelerated motion in the y.